and welcome to Kenzan. My name is Paul Barry. I'm a technical architect here, and we'll be speaking about Git. How many people here have used Git? Just about everybody. Okay, who has not? Okay, awesome, awesome. So the first part of this, we're going to cover. I'll go over the agenda when we get there. But let's talk about Kenzan. So Kenzan is a digital transformation company. We help companies who primarily have their hardware and data centers on premises, and we move them to the cloud using cloud providers, AWS and other options like that. So our tagline, transforming businesses that use technology into technology organizations that do business. So our primary goal is to make companies who don't technically specialize in technology leverage the technology in the best way possible so they can scale with ease. So a couple of things here, AWS certified, Kubernetes certified, Spinnaker, Google Cloud Platform again with AWS. Yeah, digital transformation consulting. A little something about me, technical architect here since May 2015, master's degree in instructional technology. JavaScript junkie. I love everything on the front end, HTML, CSS, web performance and stuff like that. A little bit of Node.js too. I'm a husband and father. I've been married to my high school sweetheart. It was actually 10 years after high school we got married, but we dated in high school, so it's a weird thing. So I have two kids, a 14-year-old boy and a 6-year-old girl. I'm an English Premier soccer fan. Liverpool is my fan. My team, I'm staying busy. I'm restoring an 84 Vanagon, and I'm an avid runner. So here's the agenda for tonight. We're going to introduce you to Git. If you've already used Git, this will be a very quick section. We'll go through it. I wanted to stop and have some discussion around Git itself, and then we're going to go into working with remote repos. Really working with GitHub, but I do brush upon some other options out there besides that. And again, we have some more questions and comments trying to kind of be around GitHub and remotes themselves. I do have a little example that I'm trying to throw together at the end, but really only if we have time. So introduction to Git. First, what is version control? And then we'll get into what is Git, what are repositories and kind of why do we need them, and how to use Git, and then some advanced usage. So what is version control? Wikipedia says that it's the management of changes to documents, computer programs, websites, and the such. But why do we care? Why do we want to track this stuff? It's important as we collaborate and build software that we kind of take notice of what's coming in and what's changing behind the scenes. When you have a small team, it's very easy to see changes come in. You kind of really collaborating very closely. But larger teams at scale, sometimes 20, 30 people, scaled across the world, sometimes between time zones and all that stuff. So it's difficult to know what's getting entered into the code base. So it's important that we track this stuff and so we know who's doing what and where they're doing it and most importantly, why. So there's a couple of version control options out there. Git by far right now is one of the most popular in software development. Mercurial and Subversion are also out there. I actually started with Subversion about 10 years ago, and there are others as well. I think CVS is a couple, so there are others, but Git we'll be focusing on today. So what is Git? Git's a distributed version control system. Distributed meaning that it's every user of the repository gets the same versions in history. It's always the same distributed throughout every client that's using it. And what are repositories? Repositories, and you'll see here, each of the three computers that have the repository are all kind of the same. They're all identical, trying to stay in sync. So how do we use Git? So how we use Git, let's understand what it is first. It's a globally installed command line tool. It provides simple ASCII type UI elements as well for merge and logs and stuff like that. You'll get a little bit of ASCII code to kind of spice things up. And you initialize it on a project by, a directory by directory basis. You can nest repos, but I wouldn't suggest it. It gets confusing at times depending on where you are in the directory structure. You got to really pay attention. So project directory, each one. So I'll briefly go through these. If there's anything here that you're not familiar with, you want me to expand on a little bit more, just throw your hand up. We'll stop and we'll talk about it. So initialize a Git repository, Git init, very simple. You start in a previous screen, just kind of basically says initialize an empty Git repo. You're going to clone a repo. We're pulling an existing repo from a remote server. We have Git branch, creating a new branch. There are shortcuts, and I'll talk about those later. Checking out a branch that already exists, adding a file, Git commit with a small message. There's ways to have larger messages too. Each one of these, I'll go in a little bit deeper with arguments and stuff later on. Git status, checking the status of the current working directory, whether you have stage files, whether you have unmodified or untracked files. And Git stash, you temporarily hide your files, file changes, so you can work with remotes or pull down other things. Git merge, we're merging branches, one branch or more into another. Git rebase, you're rebranching off of a branch and then continuing on with your work. Tagging, you're adding annotations to certain commits in time so you can reference back. There's Git remove, RM, you're removing a file from the repo. This is something that some people may use the file system for. And I actually suggest using Git for this, simply because it allows Git to really know what you're trying to do with it. There are times when the file system and Git cross streams, or if you delete something accidentally or you rename something and you try to put it back, Git gets confused sometimes and you may have duplicate files, or it may say that it's not there but it is there. Try to do that. And the same thing with move, MV on the bottom there. Same type of thing. Let Git handle that stuff so it's kind of aware where the files are moving. It's important when it comes to the repos to keep that stuff in check. So Git pull on the second column. Git pull, we're pulling from a remote. Git push, you're pushing a remote. And Git diff. That's a large one that has a lot of arguments that you can really work on to get different types of formatting and stuff. And that's really where you get into some of the ASCII art that Git uses to kind of highlight changes between files. So this is something that always comes up with projects, is whether we should merge or rebase. So the scenario typically goes like this. Experiment was cut from master, but master has another commit. And you see that by C3. So master got a commit that's not on experiment. Experiment makes a new commit there, and that's commit 4. Now, with a merge, we're going to actually create a new commit of that merge, for that merge, I should say. And that's shown here. Now, when we want to bring the experiment work in, or at least bring the work from master up until experiment, there's going to have to be a merge somewhere along the lines. This represents it's happening when we bring experiment back into master. There's a three-way merge going on here. There's a merge going on between C2, C4, and C3, kind of figuring out where the diff is, what changes have been made on experiment, and then bring that in as cleanly as possible on C5. Now C5 is considered a merge commit. And it's not terrible that you have these merge commits in your history, but they're just that. It's just saying at this point in time we merge the branch. Okay, not so bad. But let's look at another way. So here's a rebase. Okay, so what a rebase is actually saying, let me take my changes that I've had and apply them to what's already on a branch. So here's the scenario now. Experiment had C4, but we rebased off of master, which included C3. So we basically said, instead of merging off of, let me step over here. Actually, I think I have let me get this. Try this for you. All right. So we branched off here for experiment in the last example. And we committed here on master. What a rebase does is basically takes this and temporarily stashes it in memory. Then brings in C3 into experiment as clean, because there's nothing to conflict it. None of the changes from C4 are in place at this point. We're really just bringing experiment up to speed. Then we replay C4. Whatever C4 was is then played on top. If there's a conflict, you'll manage that conflict during the rebase process. And then when it finally ends the rebase process, you come in at C4 with all the work here. So now you're in sync. The end result of C4 here and C5 in the previous example are identical. The files at the time are identical. The difference is your history. You have one less commit here. Now, one less commit here times 1,000 commits in the next couple of weeks, months, whatever, you're going to have these merge commits just cluttering up your history. And it makes it a pain in the butt when we start to try to squash commit, or if we're trying to revert to something that maybe, hey, we realize there's a bug here. We found where the bug happened. Let's go back until we can find a patch for it. Those merge commits throw a lot of clutter and that you don't necessarily need. So I have an example, and that's what I want to show later. Is a very simple rebase example later on, but I hope to get there. So let's keep moving. Wrong way. Here we go. So we talked about some basic stuff, and here's a little bit more advanced stuff here. So Git Log isn't necessarily something that is difficult or advanced to use. It really just displays the history of the repo. What's really advanced is you'll see some of the formatting that's in there. You kind of have to understand what this means, what you're trying to display, what's important to you, and that's why I kind of left it in this part of the presentation, because you have to kind of dig into the documentation to know what's important about the commit histories that you want to display. One way around having to type that constantly is Git aliases, and we'll touch upon that in the next slide. Git cherry pick. If you've never used Git cherry pick, this is a great way to steal other people's work. So if you can see that somebody else is working on something, let's say you guys are working on something similar, but developer A has completed something first that developer B could really use and leverage at this point. Developer B could then cherry pick a certain commit over to his branches, and now he has that commit in his work. Now conflicts take part in that, so you got to worry about that. You got to make sure that the commit isn't too much. So you have 8 files in that one commit. You're going to end up cherry picking the whole commit over. So make sure that you're committing small things and you're being really careful with what the commit is when you pull over. Again, if you have those merge commits, this is where stuff like this could really throw a big problem. You just merged in a big, you just cherry picked a big merge commit because you copied and pasted by something by accident. Moving on to Git reset and Git revert. Both of these use with care and read the docs to understand what you're getting into. Git reset has a hard and a soft option. A soft option will keep your local changes and it won't really wipe them away. A Git reset hard will actually wipe your stuff away, and you're going to match whatever you just said. If you say Git reset hard remote or whatever, you're going to match that, and then your stuff is gone. So be really careful. Git revert, that's a command I've never actually typed myself. I use a GUI for that because I want them to revert it and I want a history there. So I do all my Git revert in GitHub if I need to, or Bitbucket, but we'll get to that too. Here are Git aliases. This is a new technique that actually I've never used a Git alias. I use bash profile aliases, so it's a little bit different, but technically the same result. Here's a way you can actually shorten some of your commands. So if you're really sick of typing checkout, like I don't know, it's only 8 characters or whatever. So you can change it, CO, CI, SC. But here, the last one here, history. Got my point there? Yeah. So the history here, this is where you can really take the time to get your format exactly the way you want it, and then make an alias. So you can say git hist, and then you'll end up spitting out that pretty format. So it's a nice little tool. Thanks to Peter Burt for pointing that out. So these are merge strategies. Again, I don't do much merging outside of a GUI. So I want to go through these very quickly. If you have any questions with these, please refer to the docs. You can't ask me. I have no idea what they're about. No, I'm kidding. I'm kidding. So resolve is the fastest and the easiest one. It's really just taking 2 heads and making a third. I told you earlier that there was a 3-way merge going on between the diffs, and this is the fastest, safest way. Recursive, this is really the one that's happening under the hood when you're trying to merge a single branch. It's just a recursive. It's the same thing. It's just common ancestors. Octopus, more than 2 heads, but trying to, it says it refuses to do a complex merge. So it's going to try its best, but it's not going to try very hard. It's going to ask you to give a helping hand. Ours is a way to merge a bunch of different trees or branches and try, but actually it keeps your current branch in the work there. So it's basically like, give me all your stuff, but I'm going to wipe it out with my stuff if there are any conflicts. And a subtree is a modified recursive merge. So I talked about GUIs a couple of times. So if I have to mention them, I don't really prefer Git on the GUI. Getting GUI with it? No. So this is GitHub Desktop, Smart Git, and Source Tree. Smart Git's my favorite. It's the one I've used the most for merging and diffs and stuff like that. But I really do 90% of my Git work in the terminal itself. It just makes for good habits. This, to me, it makes you lazy. But that's, you know, the visualization of the diff and merging, you can't beat. The terminal is just not there. So we're at the end of the first intermission. That was fast. I can't believe it. 21 minutes. Perfect. Any questions right now? Any comments? Any additions? I'd love to hear any additions to this. No? Darren?
I know I have one. The command I use a lot to revert a single file or reset a single file, you do git checkout and in the file, and it'll reset that one file.
That's a great one, yeah. Yeah, those are the types of shortcuts that I didn't want to cover. I didn't want to confuse people. I wanted them to really see the raw of what it was, but that's a good one. So Darren says, if you want to try to undo the changes of a single file, you know, maybe you tinkered with some CSS or you moved some stuff around in a HTML file and you're like, that's garbage, I just want to get rid of it. Git checkout in the file name will give you a fresh file. It'll just pull the new file from the memory and wipe away your changes.
What's the case where you would use cherry pick instead of rebase?
Oh, that's a great one. Yeah, rebase is really your working tree that you're trying to keep in sync. A cherry pick is almost like somebody else's work or another branch that somebody else has contributed to that you want to just say, I want that. You know, you
destroys history basically.
Yeah, and that's really why it's an advanced section because you don't want to throw away the history. And I get a little fun thing for you guys later if we can get to it. So yeah, cherry pick is really very specific, and that's why I said you got to be careful on the commit that you're picking because if you look at it briefly and it says, oh, that file changed, that's great, but there could be 8 or 9, 10 files changed as well that you're going to cherry pick.
I should say it destroys history, just a different way than rebase. It's harder to trace history, which is actually my question was. In a lot of workflows, merge and rebase to some developers might be used interchangeably, but right. I know that a lot of developers have preferences between, you know, rebase your feature branches, but rebase your feature branches to develop, but merge your feature branches when it's done, right?
Right,
so
right.
Squash.
Yeah, it's not.
Expand on like
it's not a matter of
changes that are benefits of each of those approaches.
Yeah, so merging and rebasing, they're not what's the word? Isolated. Like they both have their uses. To me, rebase keeps a cleaner history when you're trying to keep in sync with your development work. Merging is really what you want to happen when you're bringing into your trunk, right? Master or develop, whatever your major branch is. You want to merge that in. You want that to be seen as bringing into that, right? But you don't want clutter, right? So there's a difference. When you merge in clean, you don't get that merge commit. The file's there, and you still see that these commits were added at that time. You just don't have that extra, you know, and GitHub will show it like a gray sometimes, or I don't know if it's Bitbucket. It shows it as a gray merge because it's almost like it's like a metadata merge. Like you're not going to need this. It's just something that happens. So yeah, they certainly have their place. Did that answer your question?
Yeah.
No? Okay.
I think it's just more like that. If you think of a merge as like a zipper of commits,
right.
And a squash is like I just literally want to take this and just stack it.
Oh yeah. Oh, squash commit versus like a fast forward or something.
So rebase will detach your head,
right?
Bring all the changes and like fast forward, and then put yours on top.
Right.
Whereas like a merge, it's like if you have commit A, commit B, commit C, they're all gonna like from different branches, they'll all end up in your main line. Like you'll see person A commit, person B, person A commit.
Because it's not a, it's a
Whereas
time-based
the rebase
thing.
would be like all person A, all person B, then all person C.
Right,
Just
right.
look like feature,
Right,
not
right.
individual commits by. But it's like but it destroys history, so a lot of people get confused.
Yeah.
Like,
Right. Any other questions before we move on to GitHub? Darren, one more?
So this might be an advanced topic. I'm not sure if you cover this, but it's related to the cherry pick topic.
Okay.
You know, main thing I've always used cherry pick for is for a thing that we hate to do is a bug fix release.
Yeah, yeah.
Right? It's like if you're you're committing all these things and you're going into master and you have some bug fixes that are going in there and you have your product people that want this particular bug fix to go out to production ahead of schedule.
Right, right. It's a great point.
You can start a branch from the last production release, cherry pick that one commit over there, re-release that, and then deploy that to production.
Yeah, that's a great use case because it happens all the time, right? You get that one thing that, ooh, we want to get this in the release too, but we've already cut that branch. So it's a way to pick up these little things before the branch actually gets released. Thanks, Darren.
And often those are merge conflict free for the most part because they're not working with active changes.
Exactly, exactly. Adam, did you want to say something before we went to intermission?
I guess so.
Okay. Go ahead, yeah.
Hey everyone, my name is Adam. I'm a New York native, but I came to school here and decided to start a business here after I graduated. I told some of you guys about that before, but I'm not here to talk about that at all. In my time starting a company here in Rhode Island, I saw a lack of a real community of fellow entrepreneurs, of people interested in the ecosystem, and I really feel like that's one of Rhode Island, can be one of Rhode Island's greatest strengths, is the fact that we're so small. And we really should all know each other and be very supportive of each other. So I actually saw a TED Talk given by Arnell Millhouse, who started Career Devs. He gave a great talk called Silicon Road a couple years ago. So I kind of saw that, and we started a Facebook group 2 weeks ago. We said, hey, great name to start. Let's call Silicon Road. So we grew that group from 20 people to, we just broke 250 as I've been sitting here. Wrote a Medium article. So we're looking for anybody who's like, either you're starting a company, or you're thinking about one, or you work for one, or you just care about them. It's really just a platform for anybody in the ecosystem to provide support, get advice. I know there's a lot of really young entrepreneurs coming out of school who I think would love some more guidance on software development. So it's open to anyone. It's called Silicon Road, RHODE. And we're primarily a Facebook group, and we also have a LinkedIn group. And we're doing our first little meetup this Saturday after the Bryant University Northeastern Entrepreneurship Conference. And we're doing it in Smithfield, Rhode Island. Cool. So I'd love if y'all can join, but we can talk more about that background.
Sure. Cool. Thank you.
Cool. Thanks, man.
So that's intermission. You guys grab some food, drinks, come back, 5 minutes, 7 minutes, 10 minutes, 14 minutes, 18 minutes, 5 minutes, 4 minutes, 5 minutes, 5 minutes. you're really not doing much. You can just store and make changes and track changes and all that stuff locally, and it works just as well there. You don't necessarily have to worry about working with remotes. But because we are software developers and we're trying to make software with other people, remote repos is really what we have to go with. How many people here have used remote repos, GitHub, GitLab, Bitbucket? Everybody, just about? Ooh, some people who haven't. Good, good, glad you came. So let's go through it. So a remote repo, it's a third-party hosted solution. There are a bunch of options. GitHub, Bitbucket, and GitLab are just a couple. There's a bunch out there. So whatever your company uses, whatever you prefer, most times it's cost that really pushes you somewhere. Bitbucket was the place to be for private repos for a long time. GitHub has just started to offer private repos. So if you already have public stuff, and GitHub has the private stuff now too. So you can go there. We're going to focus on GitHub today because it is the largest. It was started in 2008. The 1 millionth repo was in July of 2010. The 2 millionth was just 9 months later in April of 2011. And as of 2018, they have over 100 million repos. So they, I just read they have about 70% of the market share of Git. So they are the place to be, and that's why we're going to cover them. So creating a new repository, it's very, very simple. You enter the name, you decide if it's going to be public or private. Like I said before, GitHub only had public for a while, and private was a cost. I believe that there is still a cost for a large amount of users on it, but I'm not exactly sure. I haven't gone into that too deep into the cost there. They initialize this repo with a README and the add, git ignore, and add licenses. That's really an option for you guys to decide what's best at that time. My personal preference is this. If I've already created the repo locally and I'm already working on files locally, I will not check this. I will not add these files. I will add them locally and push them myself. They're text files. They're very simple. Unless you need something complex for the ignore or the license, you can really you can add it later locally. But if this is brand new, if you're making it for a team and nobody's committed any code yet, you might as well add the README. That way there's something to pull down when they actually clone it from GitHub. So READMEs, I wanted to at least touch upon this because it's not necessarily something to do with Git or GitHub, but it's repositories in general. READMEs are really a valuable part of a repository. It gives the developer or the user or the visitor of the repository really the nitty-gritty of what you're trying to do with this project. So there are a handful of things that I feel that are a must in every single repo, regardless of what the project may be. First is an overview. You want to give a brief understanding of what you're trying to do. Is your project that's called Awesome Project the project that I'm looking for this particular use case? It may or may not be. There are millions of repos out there. So to be sure that I'm looking at the right one, give me a good overview of what you're looking for. Are you an Angular project? Great. I'm looking for an Angular project. Are you a Python project? Because I don't want Python. Be clear. Let me know right away. A demo, if available. This is great for a good amount of projects. Unfortunately, not every project can really have a demo. Microservices that don't really have something to show on a screen may not be possible, but whether you're creating an application that has a UI, or if it's a UI framework with buttons and modals and stuff like that, or even if you have, if it's an API and you have it hosted somewhere, put the link to the API so I can play with it. Let me see what's going on. Just give me a taste. Maybe this isn't what I want, but your demo will help me know if I do. And how to contribute. This is open source, right? If it's private, we get it. But even if it is private, you're going to have other people contributing, right? So be clear on what you want and how you want it. Do you want, certain things, unit tests? Do you want end-to-end tests? Do you want contract testing? Who knows? It could be all these different hoops that you have to jump through to get your code merged in. Don't wait until developers push PRs to you for you to say, oh, that's not how I want it. Be clear here. Spend the time. Be very detailed, and you'll never have to answer an email or comment on something saying, why aren't you paying attention to what's going on? It's right here. And I'll show you later. Actually, I think it's the next slide. But and then finally, the usage details. Like, tell me how to use this thing. Is it an API? Tell me what properties you need. Is it a UI library? Well, okay, tell me how I can integrate with my stuff. Be clear. Let me know. Unless you're hosting a full-on documentation site, like Material UI is a good example. They have a repo in GitHub, but they have a self-standing server with documentation and examples and all that stuff. They're two separate entities. If you don't have that, this is your documentation. Fill it up. There's no limit. Fill it up and do the best you can to keep it updated. And there are ways to generate documentation to do just that. But first and foremost, you need to let the users know what you're all about. So the contributing MD, similar to the way GitHub handles READMEs and takes the README and displays it on the first page of GitHub, of your repo. Contributing is similar. So contributing MD, MD is Markdown. I'm not sure if anybody doesn't know that. This is basically a way to be extremely detailed in your preferences of having contributions. The README is great if you have simple instructions. Hey, please do this, please do that. I would say once you get into subsections of your contributing, you may want to consider breaking out to a separate file. And the cool thing is that GitHub, and I'm not sure if other services do, but GitHub will actually show it and point it out to you and say, hey, don't forget to check this out before you start messing with this because you're going to be upset if you don't. So the idea of creating issues and creating pull requests is trying to expand this project and make it better, right? Whether you're just making a suggestion or if you're actually submitting the enhancement yourself. You don't want to get to the end of the line and then say, hey, you did it wrong because you didn't follow the guidelines. So we've created our repo previously. We've made some changes to the files. Now we want to push it, right? So first we need to connect to the remote. And we need to tell Git where we want to do that. So git remote add, and you give it a name and a URL. The name, typically, if you have one place that you're worried about, that's your origin. That's the name. It's an industry standard type of thing. You can name it anything you want, but your one primary place to go is your origin. You'll see in a little bit that we'll have multiple, and I'll talk about the different reasons to have that. You can rename it if you want. If you decide that I don't like origin or I have other remotes and I want to change it, you can change it. Same thing with URLs. Changing the URL sometimes, if you're moving from a private repo Bitbucket and you want to move it to a private repo in GitHub because you want to get rid of Bitbucket, here's a way that you can just change the URL to where you're pointing. Okay. Let's see. I have some notes here to be sure I got it. All right. So here's a common workflow that may require multiple remotes. So there's one team of 3 developers, and the repository is locked down. So only one person has read-write access. Everybody else has only read access. So they can't push directly to this. So developer A can set up a remote for his original fork. His fork of the original, we're going to get into forking in a minute, but I'll quickly go over this. His version of the repo, he has write access to. So that's his origin. Then he has an upstream, whereas the locked version where he needs to pull updates from. He can also then create a remote for dev B and dev C. So he can pull down from theirs too, as long as their remotes have him as access. He has to be a contributor on there and have access to it as read-write, but he can do that and pull it down, and then he can start playing with that stuff there. So as you can see, you can have multiple remotes for multiple reasons, and it gets a little complicated if you don't, juggle them correctly, but it's one of those things that is real powerful. You don't have to constantly clone. You can start to help other developers on the team. Oh, let me just pull your stuff down and I'll take a look. That's not necessarily if you have read-write access on the repository itself, but you don't always have that. So HTTPS versus SSH. So these are the 2 main ways of cloning your repo from a remote. HTTPS is easier and less secure. You need a username and password. It's usually a one-stop thing where you set it and it kind of stores it in memory. SSH is a little bit more difficult to set up. You got to generate SSH keys. You need to then put them into GitHub and make sure that GitHub is associated correctly. It does give you the chance to have multiple accounts though. At Kenzan here, we work on with multiple clients. I don't know if you noticed in my profile side at the beginning, I have 2 GitHub accounts. I have one for personal projects that I keep separate from my work account. But that allows me to have a work account, a personal account, a client account. I can have multiple accounts all on the same machine. I just have to set up multiple SSH keys and allow me access there. Once we have that, we can git clone in the URL. It doesn't matter which one it is, if it's HTTPS or the GitHub SSH, it goes in the URL. And the directory there, that's an optional one. I don't typically use it. I usually just let the project name dictate the name of the directory, but if you wanted to change it and name it something different, maybe you are cloning it from a fork and you want to have both versions, whatever, you can change the names. So contributing to projects. Has anybody here created PR on a public project that you did not own? Did you get it in?
Yeah.
Nice. I know you. So we're gonna talk about some of that. We've really stressed over the years here. So we've stressed here at Kenzan at most of our meetups to look at the code. If you want to contribute, pull it down, put a pull request up there, and we'll get it in. Fortunately, we've never really gone over how to do that. So I want to do that here tonight. I want to show you kind of how to get a fork working where you can make changes and get a pull request going up. So if you've never done this before, let's take the ride together.
For shade, I say we have 0 stars.
You have you do? That might not be you. That might not be you. All right. So what Owen's saying is Owen runs. Owen's part of the Provident Geeks, pvdgeeks.org website, and these are the pull requests and the issues from that. And he was upset that he doesn't have any stars, but that's not him. That's from the dummy repo that I made for this. So, but he does have 24 issues, and I'd like to talk to you about why there's so many. So we'll get on, and especially these two that are mine since October. We'll talk about that. Okay, so let's go. What the fork? So what is forking? Forking is, let's see, how do I have it here? It's basically saying, clone this repo to my account on the server. Okay, I'm pretty sure that this is a GitHub only term. There may have other things that they call it in Bitbucket and other things, but I'm pretty sure that forking is GitHub alone. So you see here that I created a fork of the website front end. And my version has no pull requests and no issues, and it's not even an issue tag here. So this is completely separate. This is my copy, my version of the website front end from Providence Geeks. But you notice 37 commits behind. So Owen's been working, and I have not been staying up to date. So contributing to projects. The first thing you want to do, find a project that you want to contribute to. Not all of them are created equal, and not everyone is going to be possible for you to contribute to, either because it's out of your skill set, or they're not looking for public contributions, or you just aren't capable of doing it. Who knows? So find what you like and that you're able to contribute to, and fork a copy. It's free, doesn't cost anything. Nobody will yell at you or ask you why you did that. You get a copy, and no harm, no foul. Then clone your fork locally. So pull your version to your local machine so you can start making changes. And I immediately, from this point, I add an upstream remote. I make sure that I make a second remote called upstream, so of the original repo. This ensures that when that repo changes, like Owen's 37 changes, I will then have access to that later on. Excuse me. Then we make the changes that we want. Whatever enhancement we're going to try to make, whatever changes, we just make them as desired and push it back to origin, not upstream. Remember, that's read-only. We had to fork it because we don't have access to it. So we push back to our origin. Now, on our GitHub account, we have a branch for this repo. We're going to go visit the upstream repo in GitHub. So not ours, we're going to go to the original. We're going to create a PR there. That PR is going to be sourced from our fork. And when we cut over to GitHub later, I'll show you. There's a drop-down menu that you can select your fork. It'll list all the forks that are there. Yours is usually at the top because GitHub's smart enough to know it's you. Once the PR is created, you just have to resolve whatever the owner is interested in, whether it's, like I said earlier, unit tests aren't there, or you didn't follow the contributing MD correctly, you need to do this and that. And then from there, the owner will merge when ready. And then you have it. You have committed to a public repo. But now Owen's going and made 37 commits, and I can't make a new one because I don't have the new work. Maybe the new work that he's done in those 37 have already fixed what I wanted to fix, or I need to build upon, right? Because I'm looking at the website, and I'm looking there, and I'm saying, wow, this looks good. I know I can fix that. But I look at my version locally, and I don't have that there. Why? We're behind. So this is what we got going on. Now, here's my little pointer. This arrow here, we don't have this arrow. So this is a bad, I didn't make this, I just copied it. But so this arrow here is, you have to ignore it. Oops. We have to ignore that arrow because we can't push to it, but we can pull it down. So here's what we want to do. The original upstream is where we want the code to end up, but it's not on our local machine. So the first thing we do is, I always start with a clean repo. I go back to master, I make sure that I don't have any untracked changes or anything that is going to potentially cause a conflict. I want to be as clean and close to those 37 commits as I can. So that means no extra junk. And then I I confirm that my remote is correct. Yes, I want to pull down from the PVD geeks and not from anywhere else. I pull my upstream master, I push origin master. And then I repeat as necessary. So, if we step through with Owen's 37, I pull those 37 changes, now I have those 37 changes locally. My local machine and Owen's original upstream match. I simply just push to my origin, and now we're all in sync. I can then start building again. I can start making more and more PRs and commits and changes that way, because I'm local. Now, this happens very, very often in our world because we're constantly trying to keep in sync. Over the weekends, time zones, all this other stuff, you can't predict when people are going to be working. So you may be in sync by Friday, but by Monday morning, you're out of sync. So what do you got to do? You got to repeat this every single Monday morning, every single Friday night before you go. You want to make sure that you're always building on. This is something that should become so simple and so ingrained in you that you're doing it. If you're working in this environment, I should say that first. If you're working on a team that you have to constantly keep rebasing, keeping up with upstream, you want to constantly do this, almost like a daily basis, because you have to assume people are making changes behind your back, and you don't want to end up having conflicts that 8, 10, 12 hours later that you got to realize, oh crap, I did all this work. Now where do I need to undo? So the best way to do it is just keep it up and keep rebasing. So I'm hoping this works. Don't like live coding. I got 6% on the battery. Jess, do we have a plug?
What kind do you have? Old one or the new one?
Old one.
What about a couch over there?
Yes.
Oh yeah, is there one right in here? So let's try this. Like I said, I don't necessarily care for live coding, but we will give it a shot. So here's a little repo I created. It's not great, and I did that on purpose. The README is lacking and could use some work. If you look at the HTML, thank you very much. HTML has CSS and JavaScript all within it. So this was my way of saying, hey, if you guys get your computers, you want to tag along, go ahead, pull requests, right? So we're going to do something different though. We're going to do something along the side here, and let's see, do I have it? Yep. Okay, so here's my master. Okay, you can see I'm in this file, this directory. Give me a second. Live coding. Oh yeah, no problem. Let me know when you see it. Good. Okay. Okay. So I want to add something to the README. Okay. So let's create a branch. Git checkout branch. So this is the shortcut I was talking about earlier. So this is basically saying I want to check out a branch, but it doesn't exist yet. So I'm going to create a new branch. I'm just going to call it README updates. Okay. So we're on README updates. Now, for those Vim lovers out there, it's going to So let's come down here. Not. Okay. Oh, that's one line, huh?
It's one line. That's
Yeah.
fine.
Okay. How do I get to the end of the line? Huh? What? Dollar? What? Okay. I'm just going to add it to the top because I don't really mess with it. Okay. So some text that should cause a conflict. So that's my game here. If I want a conflict that I have to rebase, I won't be able to merge in. So I'm going to escape there, save that. And we see here. So I have an alias, GS, Git Status. You'll see it's the same thing. This is just a bigger. I have short it, make it nice and clean. So you see that. So the README's dirty, right? The DS store is an untracked file. So I'm not worried about that right now. But the README is dirty. So let's get the README in place. So git add README. You can also do git add dot, which will do the entire directory. But at this point, it would include DS store. And I don't want that. So I'm going to do specifically say git add README. So now README is here. I'm going to check again. I always check twice to make sure that only the files that I want to commit are going to be committed. So update README. So if you remember from one of the slides, git commit with the -m allows me to add a little commit message. And there you go, one file change. So I can push origin. So if we come over here we go. Excuse me. GitHub noticed that there's been activity on the repo, and it's asking me if I want to compare and add a pull request for this branch. So let's take a look at it. And here we go. Here's the change I've made. Very, very great, amazing, right? I'm just going to create the pull request. Now, that's bad practice. I should have a description in there, right? I should have something to say, this is what I'm doing, this is why I'm doing it, this is why you should care I'm doing it. There are special files similar to the contributing MD in the README, license MD, code of conduct, but there's two others, pull request template and issues template. They're both markdown templates that you can put into your repo, and GitHub will identify them and put them in place. So let me go back and edit that. That's just the top there. So if I had a template in place, I could have something here in HTML comments saying, please, there we go, see? Please be specific. Is that right? On an angle. Okay, so I could put that comment in a markdown file, and when I update the comment, it's not there. So it's because HTML comments are not rendered in the box or in HTML. So you can put in comments into instructions behind the scenes for the user to add specific information, what ticket number you're trying to reference when you're creating a new issue or a new pull request. You can say, this is an enhancement ticket based on this user or blah, blah, blah. So you can be very specific in the instructions to ensure that the description coming in has all the information you're looking for. So we're just going to merge this in. Okay. So I'm going to delete that branch. That's just tidy. It's another thing you should be doing is keeping tidy, getting rid of stuff. So let's go back here and we see that. Okay. So here's what we got. We have a remote with an updated master. Okay? I have a local that has an out-of-date master, but an updated branch. Okay? So if I try to branch off of master, I'm out of date. And any changes that I try to make and push are going to cause a conflict. So let's do that. So let's go back to terminal, and we're going to check out master. But I'm not going to pull master. I want to stay out of date. So let's just branch off of that. New branch, and let's call it broken. Okay, so let's go back into the README. So we get out of that, go here, whoops, check, readme's dirty, add the readme, readme's added, another readme update. Okay, I'm going to push broken. Okay, so we should come over here. It says we got broken. Uh-oh. Can't merge it. Thank you, GitHub. I appreciate that. This is one of the most powerful things about GitHub is that it doesn't let you be stupid. It makes sure. No, I'm serious. Like we work so fast and we type so fast that we lose sight of things sometimes, and we're just trying to get work in. Friday, 4:30. What do you think? That thing doesn't come up. You're merging in. See you on Monday, and then what happened? There's a big merge conflict. Things broke. You're gonna get called on Saturday morning to come in and fix it. So these tools, they're valuable, and don't rush through and pay attention to these warnings. Oh, wait a minute. Why is it red? And it's because there's a conflict, right? So what do I do here? I can create the pull request, but it's not going to let me do anything. Conflict in files. Okay, great. I know that. So here's the demo part. So here's the rebase. So we're on broken. We have changes in broken that we want in master, but we can't get there. So let's go rebase. Check out master. Okay, still out of date. I'm going to pull master from origin. Great. Now, it says here, with my little pointer, right here, 4 lines added, or 4 entries added to the README. Great, that's what I want to know. I wanted my updates. So what do I do now? Well, broken, the PR is still broken. Nothing's changed over there. I haven't pushed broken back up yet. If I try, wait a minute, but I pulled down master. Here's the rebase. Let me clear it. Git rebase master. Ah, we have a conflict. Okay, and it's telling me that, which is good. It's what we want, right? It's telling me I have a conflict on the README, and I should fix it. So let's fix it. Never done it in here before, but let's figure it out. Oh, here we go. So it's going to tell me here. So this is on the head, right? And this is what's coming in. Okay, this line here is a separator between the two. So if you've never worked with Git in the diff, this is what it looks like. Okay, so what do we want? We actually want them together. We want both lines. So let's figure it out. Whoops. Got to remove the crap that I don't want, right? Okay, that's what I want. That's how I want it to end. I'm going to do it like that. I'm going to write that. Okay. Now I've updated README, but I'm still in the rebase stage. Why? Well, because now Git needs to now commit and move forward and end this rebase process. So I'm going to say Git Rebase continue. And that's basically telling Git, I know that you stopped this rebase process because of something, but I'm ready to continue here. There are 2 other options. There's rebase skip, basically saying, ignore this patch. I don't care about it. Leave the conflict, which is a terrible idea. There will be times that you use rebase skip, but it's a pretty unique situation when it comes to merging diffs that actually aren't diffs that just seem different. It's weird. You'll see. And the other one is Git Rebase Abort. So that basically says, nope, end it right here. I don't want to deal with any of these problems right now. Just end it. Get out of this rebase process. So we're going to rebase continue. Did I not? Oh, I did not add? Oh, yeah, you're right. Okay, sorry about that. Let's go back up here. Yeah. Yeah, little star I missed. So we're going to go back to Git Rebase Continue. Applying. So it says applying another README update. That applying is actually the commit that I added. So what a rebase did, and I mentioned it earlier, we took the information from master, and all the diff from master went into broken. Then we reapplied any of the commits. If there was 100 commits here, it would have said applying and went all through all the 100 commits laid on top. Anytime one of those commits hits a a conflict, we stop and we have the same little thing where it says rebasing 5 of 100 conflict, and you got to resolve the conflict at that point in time, and then rebase continue, and it continues on applying the commits. So it's really like you're bringing any changes that have gone into master, you are restarting your branch off. Now that little commit conflicts that we had was because I had changed the exact same line. If I had changed the line lower down, it probably went right past it and said, nope, there are 2 separate changes here, neither one of them conflict with each other, keep them both. And that's what would have happened here. So now, we're clean. So I must have the changes, right? So let's check it out. Well, we know that we saw, yeah, both of them are there now. So we can quit out of that, check it again, and now we're going to do something that I don't recommend, but I'm going to do it anyway. I'm going to force it, okay? So, I have no choice now, right? So here's the deal. Once you rebase off something that's already on master or already on the remote, you're changing your own history. And when you push back to broken, you're changing the history there too. So if I tried to push here without forcing, Git's going to yell at me. It's going to say, you're out of sync, something's wrong, your history has changed. You need to pull down the existing stuff first before you go back to work.
Can you show us that? Just run that before.
Oh, sure, yeah. Okay. So it's basically telling you that there's an out of sync history. You have now applied the new history from master that got merged in to broken, but broken has an extra commit now, so we need to sync them up. One way is, and it suggests here, hint, pull it. So I can pull it down and work with the merge locally. That's another merge commit potentially. I don't want to deal with that. I know that my team is not messing with my branches. That's kind of how we work around here. If you have a branch, you're on your own branch. And that's respect. We say, nope, that's yours. It's not until you almost get welcomed in and say, hey, can you help me here? You can make changes here. It's cool. All right. But then it becomes a different type of communication. It's, hey, I push something. Great, thanks. And that user now has to pull down and manipulate. You can't force push at those times because each history is now separated onto 2 separate machines or multiple machines. And trying to sync those histories together is nearly impossible. So, because I know I have the respect of my own branch and nobody's going to mess with this, I can push this with a force. And it's not going to complain, it's just going to say, go ahead. Come back over here. Oh yeah, it does it for me. It's ready to go. It says 2 updates here. Why? It's cached. If I refresh, it should only have 1. Okay? But you notice, I don't know, I should have showed you before. There was different hash numbers because the history changed, right? So now we have only 1 commit on this PR because it's only 1 new entry going into the master. Okay? Any questions on rebasing in this little example? Darren, man, you work here, dude.
You mentioned that you don't like to do the mindset, but how would you do it differently? Is there a good way to do it that you would prefer to do?
I only suggest not to do it because you have to use it with care, right? So as a professional teaching people, I don't want them to do something and say, hey, you told me to do that and it was messed it up. So I tread with care when I teach people this stuff. Using that -f, it really comes down to your team and who's using the project with you. If you're on your own repo, force all day, who cares? Because nobody's going to be messing with it. It's really when you have the chance of somebody else messing with things behind your back that you don't even know it's there. And you don't want to wipe out somebody else's work, you know? They spent all weekend working on it. You come in Monday morning and how come I'm out of sync? Boom, force, done. This weekend was ruined. So yeah, there's not really a better way than pulling down and doing it that way and merging and having that crap. It's just part of the game, unfortunately. So you can use force, just, use it with care. Any other questions?
Just curious, you actually use command lines for the merge conflicts, or do you have a tool you like to use? Oh
yeah, I do use the tool for that. The Smart Git is one of the ones I use. but any IDE, WebStorm's merge conflicts is fantastic. You can right-click on a file that's got a merge conflict. You can say resolve it, and it pops it up in a three-panel diff, and it's fantastic. So I can open it up. I'll have to turn the monitor off for a minute to get over there. But any other questions with this stuff? Go ahead, Owen.
Not so much a question, but I think on the topic of GitHub, would you be able to share your kind of first open source contribution experience?
Oh, my first one? Oh.
I mean, I know a lot of people I've talked to are sometimes apprehensive to contribute to open source,
yeah.
Whereas a lot of maintainers are like, I wish someone would contribute to open source.
Yeah.
So I was wondering if you could kind of share, like, from your perspective, what it was like.
Yeah, it was nerve-wracking because I had a little, story in here I didn't get to. I wasn't even watching my notes. I learned Git because I had to. It was weird. I started at a company. They never mentioned anything about version control. I was working at a smaller company before. We didn't worry about that. We were working on a network drive. How crazy is that? So they basically said, you gotta learn this. So I just did what I could to learn it, and it was really intimidating at first. I wasn't really familiar with the command line at the time, so it was really tough. So when I started getting into open source stuff in GitHub, it was a whole nother layer of complexity. Like, wait a minute, I can't just download the files. Why can't I just, they're right there. There's no download button. Now, there is now because I have GitHub desktop. Before, there was no way to just get the files locally, and I didn't know how to do that. And the forking thing added another layer, like, well, wait a minute, I already cloned this guy's repo, how can I get up there? So that's really how I structured my talk on this, was the problems that I had with my first contribution. What is forking? How do I make sure that I'm getting it up in the right spot? And wait a minute, there's conflicts now because it took me 3 days to get something done, and they've been working behind the scenes. So I really tried to clear all that stuff up today, so anybody here who's looking to make their first contribution would have confidence in doing that. My intention here today wasn't to make you Git masters or GitHub master. They're both complex systems that sure have a very easy entry, right? But to master them takes a lot of time between branch permissions and webhooks in the GitHub. I'm giving away my next slides. I hope that I at least shed some light on this and helped you guys feel more confident in contributing to anything. I've contributed to stuff that I didn't even think people would answer me on. I've contributed to Circle CI. I've contributed to Atom. I think it's Atom. Whatever. There's stuff that I just took a swing at and said, hey, let's try it. And you'll be surprised, because some of the low-hanging fruit that you think is so easy, why hasn't anybody done this? It's so easy. It's because the guys who are really maintaining that don't have time to do those little things, right? So spelling mistakes that have been there for 10 years, 8 years, 6 years, they don't have time to go back and change it, but you do. So take your time and do it. That was one of my first simple little things in one of the largest repos that I've been a part of. Was I just changed some documentation that had thrown me off. I was trying to use it and it threw me off, so I said, no, I'm going to fix it and make sure it's right. And the guy gave me like so much appreciation, because he didn't realize it was wrong, like the API had changed or something like that, and I fixed it for him. So it's those little rewards that make you feel like you're actually contributing back to something that matters. All right, so this is for Darren. People like Darren. Yeah, but what about this and what about that? Git is a development tool within a development workflow, shaped by a preferred development style. We're all doing what it takes to get work done, but we want to be as comfortable with ourselves and to be as most productive as we can. Again, I'm not here to make you masters. I'm here for you to feel comfortable using Git and GitHub, and I hope that you leave here today feeling comfortable enough to add to my little repo here today. Here's my little thing. So here's some of the stuff that I wanted to bring up, but I didn't really know where it kind of fell into place. Some of it's advanced, some of it's used every day, but it's tough to kind of know where to stop. I only have so much time and so much energy up here. So for the Git side of things, Git stuff will be on the left, the GitHub stuff will be on the right, but workflows, really this is really important, and we just touched upon this with cherry picking and rebasing and force pushing. How does your team work together? Come up with a workflow that you guys can appreciate and can really get down behind, because you're going to be working with it for a while, so you might as well be comfortable with it. Git Flow is one that we work with, and I know Owen is a big supporter of that, where you have a master and a develop and a releases branch and feature branches, and you have all this stuff going on. It's a real great way to really keep things separated and isolated, and you don't release anything you're not supposed to release, which is a really great thing. Excuse me. Then there's trunk-based development, which is basically there's only master. Short-lived branches come right back into master, and master is always getting released. That's great, except it's hard to have half-baked things in preview form. Something's getting built by another team, but I'm half-baked with my stuff, but I want to be able to demo and show it, but I can't go into master because that's going to release to production, so where do I do it? And it's a pain in the butt sometimes. So sometimes it's just best to have a development branch with a development environment that you can preview stuff as you go, and then when everything makes a cut, boom, you push it to master. So work with your teams, find the workflow that works best for you and them, and then stick to it. Don't fall off unless you guys agree to change it and say, hey, we're not going to do it this way anymore. We all agree to go this way. It's really important. Communication is key there. Git hooks. Git hooks are a way to control different actions based on different scripts based on Git actions. So there's a Git Commit Hook. So if you want to lint files on commit, you can do that. There's a bunch of other ones, commit and pushing and stuff like that. So it's a matter of finding what works. Again, not everything will work for everybody. Some people find this intrusive because you're trying to just work, and one of the things that people teach you is commit often. So if you're committing often, you're constantly running these scripts over and over and over and over, so it can slow you down. So be careful with what you kind of set up, and keep everybody's developer experience in mind when you're doing it. The ref log. So the ref log you'll hear a lot about when you're talking about cherry picking or you're trying to reset and revert things. It's basically just a log of traces of where each commit kind of lives and stuff like that. So you don't want to really mess with, that's kind of where the history lives and stuff like that. So you don't want to rewrite the ref log, you don't want to mess with it. You can leverage it to make changes, but don't mess with it itself. GitHub pages. This is something that they introduced quite a while ago now. It's basically self-hosted websites based on your repo. So I mentioned earlier, if you had a self-hosted document server, this could be one alternative to that, where you can use your repo to generate HTML or whatever and spit it out into a specific branch that GitHub identifies, and they will actually host an HTML file there for you, files there. So that's one thing, one feature. Webhooks, very similar to Git hooks, except they're on GitHub Actions. So we created a pull request. I don't know if you guys noticed, but there was a little message that said no continuous integration implemented or something like that, right? You caught that. That's what this is. It's a Git webhook type of thing where when you create a pull request, you can then trigger a script. We do it with continuous delivery and integration, where we have a Jenkins build or a Circle CI build, kickoff, run a select group of tasks to confirm that the code that's going into master is linted and tested and polished before it goes in. So you can set up a bunch of things for that. And branch administration, I touched upon it earlier, but it could be a whole talk in itself, making sure that the right people and the right groups have the access that they need, and you don't want to give away too much. And many more. I've always loved that at the end of those time life music things. Thank you. There was one last thing I wanted to show. So I got resources here. So they're in no particular order. It's basically just what I grabbed and I threw up there. So this one down here, though, I wanted to show you. So this is what that repo is. So it's a repo of do's and don'ts of Git. I tried to make it look like a terminal. I have not done CSS in a long time. But this is all browser. There's no images here. This is all browser. So please pull requests, images, break out the CSS, change it. So we can go over some of these. We have a little bit of time if you guys don't mind. We'll go over. So we'll go back and forth, and I'll kind of expand on each one. I added this little blinker here. I wanted to point that out, like a terminal blinks. Okay. Is it too small? Let me bring. Yeah, yeah. There we go. So it blinks when you hover over. So we'll go back and forth. So do commit early and often. This is really important when it comes to working with teams and stuff like that. You want to make sure that first you're not losing work. You don't want to have to stash stuff and move stuff to the side and have all these uncommitted files and all this big work, and then go one time in. You're really going to hurt yourself down the line. You know, early on, sure, you want to have your README and a Git ignore and all that stuff, all one big push. Sure, but as you start to build features and you're really starting to work in these repos, keep things short and concise and grouped together. If you're making CSS changes, keep all the CSS files together. Or if you're making a component, keep all the component files, HTML, CSS, all together, and get that together and pushed up there and committed. So try to keep them small and concise. And don't panic. Don't panic. A lot of this stuff can be fixed. Right? At the very least, you have a remote that you can pull down and start the day over. If you're committing early and often, you're not going to lose a lot of work. You can easily go back to a previous commit and say, oh crap, okay, we just stop this. I went to lunch and I came back and I forgot where I was. Let's just start over. Choose a workflow. We already touched upon that. But yeah, it's important to know what's going on. Oh, that's a little weird. So don't change publish history. That's the force that we talked about earlier. Be very, very, very careful when you're working with teams. You don't want to mess anybody else's workflow up. Divide work into repos, with the exception of monolith. I know monolith is something that we can talk about. I didn't want to really touch upon that because that's an approach to using Git in repositories, and I didn't want to get into approaches. I wanted to kind of hit the bare bones. So divide it though. If you have microservices dealing with user profiles, try to keep that separate from microservice that you may be using for images or something like that. Same thing, Owen does a good thing where the PB Geeks website has a front end, but also some back end code separated, so they're separate repos. They could easily be kept in the same one, but they're split out so you can really focus on the particular nuances of that project. So if you have a specific webhook that you want, you can set it up for just that particular repo as opposed to setting up for the whole project. Don't commit generated files. This is something that you can just assume that we can regenerate at any time. Most generated files are generated at when they're generated at runtime. They have configuration or environmental variables that are going to change what's happening. So if we potentially commit them, those settings could be locked in and hard-coded into it, and we don't necessarily want that. Make useful commit messages. You want to be able to read the history when you come back to it. Be very clear. And this goes back to choosing a workflow. A lot of times that's part of the workflow discussion is what do the commit histories look like? Do we include ticket numbers? Do we include GitHub little fix and chore and stuff like that, little keywords that can be picked up. It's important to just agree upon it. It's important that everybody's concise. So when you're making change logs or you're looking through the history for a particular release candidate commit, you need to make sure you know what's going on. Don't commit environmental variables. Again, this is something that will be different per environment. You don't necessarily want to share them, especially if you're using passwords or secret keys and stuff like that. You don't necessarily want them committed into GitHub. Even if it's once and you remove it, it's there. It's in the history, you can go back, you can see it. It might be red because you removed it, but it will be there. And there's actually, I don't remember the details. There was a bot or something that was scanning repos, public repos for AWS or user keys, and they're just looking for simple keywords, SSH underscore or something like that, and they were pulling out files that they could find. So even if you accidentally push it, make sure you get it out of there as soon as possible and try to bury the commit, but be very careful. A README, bless you. A Git ignore is a very good file to set up right away, so you're not accidentally committing anything that you don't want to. Keep up to date, pull and rebase. We covered that pretty extensively, so that's not a thing. Here's reset. Again, don't make the mistake of overriding your files by using hard or merge. Make sure you stash your stuff out to move out of the way before you try anything like that. Do periodic maintenance. Make sure that you're deleting old branches. You're deleting both on locally and remote. Make sure that you're updating your readmes and make sure you keep the repo itself fresh. You don't want it to look stale.
Do you have a good strategy for cleaning up local repos? Because it's easy in GitHub, but like at halfway through the project, I have like 50 branches.
Yeah. You can use wildcards. That's what I've seen. And you can chain them. So you can do like a git branch delete, branch. So other thing, let me see if I can show you. I know that iTerm, I think it's iTerm, maybe it's, you don't necessarily have to copy paste something. You just have to paste it, and I'll show you how. Watch. So if I do this, instead of copying and pasting with the command C and V, I just command V, and it pastes it for me. So a good way to do it, if you have a bunch of things, you can keep your cursor here. Let's see if I can do this, paste, do this, paste, do this, paste. I never have to go back down, right? So, you have to push the space button to get the spaces in there, but you don't have to go back and forth, back and forth, back and forth. Periodic maintenance. Don't use clean without an end flag. Yeah, I didn't go over the clean command because I didn't want to even chance you guys doing any of that. Enforce maintenance. Yes, it's that important. There's maintenance because it's maintenance. Make sure things are cleaned up. Just don't get bloated. Don't use pull with a branch argument. I tried this, and there's an extra configuration that you need to do to make sure that this doesn't happen. So you could potentially, let's say you're on my broken branch, and I say git pull origin master. It's going to try to merge master into my branch. You don't want that necessarily, so just be careful when using a branch argument when pulling that you're on the branch you're trying to pull. You don't want to, that's thrown me for a loop before that I'm just all messed up.
Without a branch argument,
it should be the current branch, right, but I had problems with it while I was trying to test this stuff to say, and maybe I can even show you. What the hell? I don't know what happened. With a new tab, maybe? Is that too small? Okay, what are we doing here?
When you leave off the branch name, when you do git.
Oh yeah, so if we do git pull, see, yells at me. Now it says that I need to look at git pull details or set this up. And I thought that was odd because I hadn't seen that before anywhere. When I was reading up on the.
Does that mean you don't have a remote set though?
No, it's just saying that the setup upstream to origin. It's weird for me that I need to do this every time.
Well, if you do a git remote -p, they do it in origin.
Right. So if I do git pull origin, it's going to yell at me because I don't have a branch now. So now I have to have the branch. So it's weird. So I tried it because I found the do's and don'ts kind of early on in the presentation, and then I wanted to kind of make sure that they were all working before. And I got a little hung up on that one. Enforce standards. Again, making sure everybody's playing by the same rules. This goes for not only your team internally, but anything that you publish publicly, you want to make sure that they're playing by the rules too. Don't change where a tag points. This is kind of the same thing. You're changing history. You're changing references in the ref log. Don't mess with that. Use useful tools. Whatever's working. If the GUI works, use it. I don't care. Just whatever works for you. This is another way to rewrite the history. This git filter branch is just a way to filter branches and find out commits in there and stuff like that. Integrate with external tools. Integrate with Slack, integrate with Jira, integrate with these things so that when stuff is happening on GitHub and you're not really paying attention, you're being notified. Whether it's your email, you have your email client set up to put all the GitHub emails in a certain directory, or your Slack, you have a Slack bot that's just ripping out these things. Don't create orphan branches. Orphan branches, I didn't touch upon them because I didn't want you to try to do them without knowing that they're really bad. It's basically creating a whole new trunk. You're not taking any history with you. You're not taking much with you at all. So you can't come back. GitHub Pages actually suggest this. This is their way of saying we're going to disconnect it from your repo totally, and we're just going to have its own path and its own history. But that's the only reason why I've ever used often argument. So these last three here, keep your files in a separate commit. So when you're moving and restructuring things, sometimes it gets confusing that you moved and added stuff. Now, it's difficult to know in GitHub and to tell in GitHub that you've just changed the file name and made a change. But so this is suggesting if you're going to restructure things, you're going to say, okay, all these are going to go into its own directory now. Do that in its own commit, even in its own branch if you can. It's much better that way. That way we can all start from the same spot. Name your stashes. I touched upon stashes earlier, but you can name your stashes so you can come back and reference later. And you keep your branches tidy. We talked about that, deleting them and making sure. This is actually the repo. So if you'd like to add, if you have any more, if you want to change it, please, I'd love to collaborate.
For the git pull done, I'm pretty sure if you do git push -u origin, whatever your branch name is, when you're first pushing for the first time,
Okay.
then git pull will always pull down that.
Oh, okay.
branch that you put up.
Okay. Okay, thank you.
One kind of neat use case I found for orphan branches is if you want to create like a starter repo, and you can have people clone off your master branch and orphan that branch into their repo, and they can start with your work, but no history.
Oh,
so
cool.
they don't have
Okay.
all your 100 commits trying to get.
Yeah, to get
you
up
can
in
just start a new repo, like say like a kind of like the output of a generator, but
Oh, cool.
you can basically say take this branch, orphan it, now that's your.
Oh, nice. I like that. Yeah. That is another use case. I hadn't even considered that.
Git fetch, you ever mentioned fetch? I kind of read that it's useful and I can't figure out exactly why.
Wow. Git fetch. Why didn't I talk about that? It's interesting. Okay, let's go back to the terminal. Git fetch. Let's talk about it. So what do you use it for? You said you don't know what you use it for?
No, I think it shows the branches, or it brings the branch names down from
Pulls local changes without actually merging them into your local. So if someone had, whatever reason, say you're working on a shared branch with someone, and they committed changes, and you also had changes, or you can. So actually, the better way to say it is Git pull is actually the combination of origin / master. Right. Git pull is actually the combination of fetch and merge in one. So fetch, if you just want to say get related to master, but you're not ready to merge it into your local copy. And then so basically do the equivalent of git pull would be a git fetch master pulls it down, git merge master updates your local copy.
That's right. Okay.
And when is it beneficial to just do a fetch and not a merge?
A fetch. So if somebody else pushes a branch, let's say Owen pushes a branch to the same repository that we both have read access to. It's not a fork, it's the same repo. Paul, can you take a look at me? Take a look at this for me, I need some help here. I can fetch, because I don't have his branch. He pushed it to the remote, but I don't have it locally. Fetch will just pull the reference down and say, hey, there's a new branch, new tag, new commit history. I'm going to pull it down so you have the reference on your local machine, but you're not merging any files. It's really just saying, give me the reference information for anything on the server I don't have yet. And that's branches, tags, or anything else. Darren?
Yeah, and if you're like a team lead, it's good to, since I don't review my team's code, but prior to when they have a pull request ready, I can go down, fetch all the branches, see all the branches, and just open the code, and I can throw your feedback.
Yeah, that's nice.
how I use it.
I also kind of consider the poor person's offline mode. If you're about to say travel, but you want to get all the code, but you don't want to merge anything.
That's a good idea.
Let
Yeah.
me pull it down in an hour when I'm on the plane. I can just go through everybody's work and just merge it.
It's not in your local, it's not in your active branch. How do you actually
It's,
see it?
without getting into the weeds, the way that Git tracks, it'll have a distinction between your origin remote that you're tracking versus your local. And sometimes you'll see the difference. Someone will type git pull origin / master versus git pulls origin that's too much in the weeds for this.
Just understand that Git pull is actually doing two things, which are two other Git commands, a combination of Git fetch and Git merge.
If you start working on, let's say, dev, and you realize that dev's advanced on the remote for you, could you fetch dev and then rebase off of the origin dev?
You'd have to stash your changes.
Yeah.
Anytime you're trying to bring anything in on the same branch, you're going to potentially have conflicts. Git may or not yell at you ahead of time. It may say, stash your changes first. You can do that and pull down and do it. Or it'll throw a merge conflict and give you the merging process that you'll have to, hack your way through to get that merged.
So you can stash, rebase, and then
well,
stash top.
if you're working on a branch and it changes, you can stash yours, pull it down, and then reapply your stashes. You don't need to rebase anything. You just put your stash back in. It'll yell at you if there's a conflict at that point. You don't need to rebase. If you're on the branch, rebasing and merging is for two separate branches. If you're on the branch itself, just stash your stuff to the side, pull down what you need, and put it right back on top.
And if there's no conflict, you just pop and it just goes.
It won't do anything. Yeah, you'll just keep working. Good.
I'm from the SVN world, so
Okay.
all this stuff is really foreign to me.
Yeah,
So
yeah.
all these little buzzwords.
Threw a truck into there here and there.
Yeah, I heard the word truck and I was like, what? Somebody touched on it where you're talking about code review. So does somebody own the master and then code reviews all the branches before those get?
Yes and no. So everybody has access to viewing master. So everybody can see it. Everybody can look at the PRs and see what's coming in there. Typically, you'll have a group of individuals that have merge power, right? They're the ones that kind of say, yes, you can go in. So on a smaller team, you may all have merge power. Typically, the way we work here is you're responsible for your own branch. It's your work. You want it done, you got to get it in. So we don't really have merge managers or release managers that kind of just sit back. I put a PR in, the review comes in, and it's usually collaborative. It's the whole team. It's not one person saying, you got to fix it. It's everybody. If you got time, you take a look at it. And it could be the junior developer that's on the team, or it could be the most senior developer commenting and saying, I don't like this, or can you explain why you did that? And that's what I think the best thing about the PR conversation is it's not necessarily always negative. There's a discussion going on and learning going on saying, this is why I took this approach and why I changed this block of code to do this. So when you own your own PR, you see it go through, you get the comments, the feedback, you make the changes, and you basically have to babysit it to get in. Sometimes there's a 25-minute, sometimes even longer CI/CD job that's going to run before you can even merge. And if you didn't put in unit test or the unit test coverage drops, you need to then fix it before the PR can even be reviewed. I'm not looking at any PRs that aren't ready to go in today because I'm assuming they need work. So I don't have time to sit and review broken PRs. So if it's not ready, it's not ready. I'll come back to it. But it's on you to make sure it's ready for me. Any other question? Dan.
I was just going to, comparing Subversion and Git. I was in that transition phase where we went from Subversion to Git, and at a different point in time, GitHub really wasn't like a thing for us. It wasn't an option for us, and you're kind of comparing the two features of the Git core versus Subversion core. They're kind of similar.
Yeah.
GitHub and Bitbucket in particular, they add pull request. Pull request is a feature of GitHub.
Right.
It's not a core feature of Git itself.
That's a very good point, and you're right. What a pull request is that layer of review. It's allowing you that extra step of saying, wait a minute, let's take a look and make sure we all agree upon it. If you have write access to a repo, you can merge locally into master and push it, and it just happens.
Yeah.
GitHub gives you that layer of security, and especially when it comes to open source in the public, you want that extra layer of security because you don't want anybody just pushing to React or pushing to something and then finding out later like, oh crap, you totally messed it up with one simple little commit that would have went in. So, and you got those not so nice people that are trying to do that and ruin other people's good times. So Darren's right, that layer of issues and pull requests is the tool GitHub, not Git.
It's very common to use a
Yeah.
But in actuality, every Git repo is equivalent as the next one. They can all just be remotes and origins to each other.
Right. Right. Any other questions? Well, I thought a lot of fun. Thank you very much. I really appreciate it.